Now we're getting to cookies, and this is where it's going to start getting a little bit more fun. We're going to start practicing some of the attacks and checking out some of the defenses. So now that we're over the DNS part and the HTTP kind of prerequisites to understand how all this works, now we can get into cookies. And to be honest with you, I don't really know how the web, how they, who sits in the standards committee and comes up with the name cookies. Who knows? Who passes it? Who knows? But cookies is what we got. And cookies are very interesting because cookies were actually, they were written in such a long time ago when the web was actually starting, and it's not at all what it is today. But they have become such a big part of the web that although we have a spec today, there are a lot of sites that use cookies in how they were first implemented, and it creates a lot of vulnerabilities. But again, they really are such a big part of the web that they're kind of used everywhere. As you can see, Netflix uses them, Google, I mean, pretty much everybody, right? And because we know that HTTP is stateless, cookies is one of those ways that we kind of keep state around, and we can create this idea of omnipresence, or and we're gonna go over what that means. But pretty much is a way to keep state from request to request without actually relying on the protocol itself, which by itself does not have a way to do that. So sessions. Let's go over sessions. And what are sessions? So cookies are used by the server to implement pretty much sessions. Okay. So and a session again, depending on who's we're depending on your use case. Let's just say a session can last as long as the browser is open, or maybe a session can last as long as until the user logs out. Right. So there are different types of session, but the idea of a session is that some information is going to be remembered for a period of time past and over a period of requests, right? So it's more than one request, and some information is going to be remembered from one request to the other request, right? So that's pretty much what we want to think about when we're thinking of session. So the goal is that the server, they want to keep a set of data related to the user scoring browsing sessions, right? So again, we see this in logins, in shopping carts. So let's say you add something to your shopping cart, and then you want to remember, hey, this user, maybe they click the back button, or maybe they remove something. So how do we remember that when a user, let's say, adds something to their shopping cart, then goes to the checkout page, but doesn't check out, and then goes back to browsing for more products? So where do we keep that information, right? Where do we keep the fact that the user already has some items in their cart, but haven't actually checked out yet? And what we want to do is we want that when they go from adding the item in their cart to even browsing more products, we want to keep adding those products to the cart, while at the same time, when they go to the checkout, we want to make sure all those products are there. But those are all different requests. So again, cookies are used to remember some of this information. And of course, ad networks use cookies to track users across different sessions. And we'll talk a little bit more about ad networks. I personally love ad networks. I think they get a lot of bad rep because of I don't know, bad actors in the network, but that always happens, right? Now the great thing about user tracking is it's the way that let's say, for example, when we go to Amazon can deliver a unique experience to each and every single one of us, right? And I think over time, if we do this correctly, user tracking, in my point of view, and again, anyone can have their own point of view, but I can just tell you the way I see things. And the way I see things is that because of user tracking, and because we were able to have our identity online, right, and track our behavior over time, services that really care about their users and about delivering better experiences, they can deliver those experiences really tailored to what the person wants. And over time, the experiences and the user experience can become such a wonderful thing, right? And they can deliver experiences that are far and above what can be delivered when there is no tracking available, right? So again, that's just my little side note on that. But again, user tracking uses cookies as well. So this whole concept that we're talking about here is called ambient authority. So ambient authority is to regulate who can view resources or take actions, right? And again, the idea is that who can do this through many requests, right? So as many requests are happening, so let's say you're going from in your Facebook profile or some other profile, and you're clicking around, but at the same time you're staying logged in. The way that happens, or your Netflix account, your Amazon account, or wherever, as you're clicking around and you're staying logged in, that's because of this ambient authority that the server sent back the set cookie response in their headers, and they gave you a session ID, and because you have the session ID that kind of follows you on every request, then this is what ambient authority. This is what becomes ambient authority, and that's the way that the server can recognize who you are, and then at that in the same way can keep you logged in, right? So, but the idea is that they can ambient authority access control based on a global and persistent property of the requester. Okay, that's just pretty much the technical term for what we just described. And there are two main types of ambient authorities. One is cookies, and the other one's IP checking. Now, IP checking is used less often, but still good to know. For example, let's say you're logged into a university library site, right? Let's say you're a student and you're on the network. But the university, they don't necessarily want to keep, they don't necessarily want to know which student or anything, because once you're in the network, they can pretty much say, hey, you know what, they're on the network, they must be on the campus, so like let's allow them access to pretty much student resources, or whatever resources that they want to give them access to. Well, IP checking, it's something that's included with pretty much every request, and that's one way to keep track of, at least at a very high level, of where the requests are coming from. And let's say that they're not coming from the IPs that from the IP that belongs to the university or the library, then that request should not be allowed. But the main way to keep track is definitely cookies, and that's what we're going to be talking about more and more, and the attacks on cookies. So let's go over really quick. And I think for me, a lot of this stuff is interesting, so I wanted to include it for you as well, because I think the more we understand this, we kind of know why these things happen, and how it evolved over time to the state of how we are today, at least when I'm recording this video. So the history of cookies. Cookies were implemented in 1994, okay, in Netscape. And they were at first described in this 4-page draft paper. You can kind of think of it like someone writing on the back of a napkin. And that's kind of how, someone got it, one of the browsers got it, I think Netscape, and then, okay, cool, let's just implement that. And, next thing you know, a week later, they were implemented. So cookies, this is all to say that cookies were implemented way before anybody was thinking about security, anybody was thinking about how the web was going to evolve, any of that. So cookies, bypass a lot of the modern day web securities standards that we have developed after that fact. But that's because they were implemented in 1994, and they were implemented in a half-baked way too, on top of that. So because the web has to be implemented in such a way that is backwards compatible, right? And again, everybody I think over here knows the awesomeness it is to make your website backwards compatible for every single browser, and the pain that it can cause when that's not possible. For example, let's not point any fingers, but Internet Explorer for a long time, it's gotten a lot more better now with Edge and all that, but for a long time, just to support Internet Explorer was a huge burden, because the standards that they had set up and the way that they implemented the standards was not the way other browsers were implementing the standards. So again, you might get your website looking one way when you access it from IE, and then if you were not an IE, you got it a completely different way. And again, this happened for a while until the standards kind of they I think they got the message, and they were like, guys, I think we have to abide by the standards, or at least get involved in this process of creating standards, so that the user can get the correct experience, and developers can code against this spec that we're creating for them, so that websites don't look just 50 different ways, and developers have to just develop in many different languages, or whatever. So that's kind of what's going on there. So cookies really didn't have a spec for 17 years, okay? Just pretty much until, I guess, recently, you can say. But for 17 years, since 1994, there was no official spec for cookies, and I'll include some of the links so you can read the specs if you're really interested in that. But I think they're incredibly interesting, and I think that they really are becoming better as far as the web security is concerned. But we're gonna go over some of the main pieces that cookies have and that are part of the spec, so that you at least you know from a web security standpoint what you should be looking at and the things that you need to do to defend against some of the attacks that we're going to talk about. So let's talk about cookie attributes. So the expires header on the cookies, when we set cookies on the API that the cookie spec gave us, has this way that we can that we can specify when does it expire. So again, it pretty much says, you know, when do you want this thing to expire? You can expire after someone closes the browser. You can expire it, you know, like 30 days from now. You can expire it even 30 years from now if you decide, right? So a cookie can live on for a very, very long time, you know, or a very, very short time. But the expires part of the API allows us to specify this. Then we have the path. So the path, at least it tries to. It doesn't do it successfully, and we're going to cover that. But for example, what it tries to do is it tries to scope the cookie header to a particular request path prefix. So let's say you are logged into to a website, right? And only when they access, only once they're logged in and they're on a specific path. So for example, the /docs path of the website, only then will the response header include a cookie. And if they're on any other path of the website, then don't include the cookies, right? So that's what the path attribute on the API tries to do, right? So again, this is one really, really weak way to for security to happen based on cookies. But you know, based on the path they are, you know, only certain cookies will be accessible. But we're gonna see later on in XSS attacks and in cross-site scripting attacks that someone can, like for example, you can get framed into an iframe, and then someone can access cookies that are not part of that path through the iframe. Okay, even though they're not on the path. Okay, so again, this is not something that that actually works. Especially attackers know about this. So again, cookies, but the cookies do have this this attribute. And then the domain, allow the cookies to be scoped to a domain broader than the domain that returned the set cookie header. So you can say that let's say you're in a specific domain, but you can say, hey, you know, I allowed this cookie to be scoped to pretty much like the whole domain range, right? So not just a path, but I want it to be scoped to the full domain, even though it's being set on a certain path. After it's set on the login page, any page after that, like just include the cookies, okay? So setting cookies. Let's see how we set that. So again, it's just the header. That's all it is. And all you have to do is to make the header, you just got to create the header. So the key of that is called set cookie. And then after that, the way you include the value of it, okay, is denoted by a semicolon. And then you can include as many values as you want within that set cookie header. So you can, you know, within the set cookie, you can call it theme equals dark, so that will be the name of the cookie, and then the expires, and then issue a date or any of the other attributes that we talked about here, and we're going to look at that in more detail in just a few minutes. So again, how long can cookies last? Sites can set expires cookie to a very, you know, like very long, like 30 years. At some point, you know, some sites were setting cookies for a very, very long time. And some users, I guess, you know, you can say that they're like, you know, why do you need to remember my identity for so long? When I'm only logging in and then logging out, like it's not a site that I'm like necessarily like, you know, like if there's no use case, but they were still remembering a lot of information about these users. Again, that's just something that the server can specify. When expires is not specified, then what happens is that the cookie lasts for the current browser session. Okay, so that's the default behavior, and that's at least I wanted to get that across so you know that. So if you do not specify the expires attribute, then the cookie will last for as long as the session, that browser session. So if they close the browser, okay, so they have to actually close the browser. Okay, if they do not close the browser and they just click away and to another, or not even click away, they go to another website, that session is still active. Okay, so that's very important to understand. Like they have to close the browser, right? They have to terminate the process. Remember we talked about the process in the beginning. Like that process has to be terminated. If it's not terminated, the cookie is still active. Okay, and then again, that's a vulnerability to cookie session hacking. Okay, so that's remember that. Okay, so how do you delete a cookie? Again, this kind of goes to how old cookies are. So you set the cookie with the same name and an expiration date in the past. That's how broken this API is, but again, that's what we have. That's what we have in the web. So you set cookie, then you set the key, the name of the cookie that you want, and then you put, for example, Thursday, the 1st of January in 1970 or whatever. You can just put at whatever time, some day in the past from where you are right now, and then that's how you delete cookies. It's completely horrendous, but yeah, that's what we got. So how do we access cookies from JS? So we saw that cookies get sent, okay, in the response header or in the client request, but the way we're going to perform these session attacks is that cookies can be accessed from JavaScript, okay, and then that's how an attacker can actually, if they again, even if you're in a different domain, but the attacker can make a post request to a server and a session is still active, then the attacker can actually include in that request the cookies of that person, and their whole identity pretty much, and then that server won't know that this is a malicious attack, and it pretty much doesn't even care where it originated from, and that's pretty scary, but it's the truth. Okay, that's just the way they are. So the way we access them, and we're gonna go over the code base, but the way we access cookies through JS is document.cookie, and then what you'll get back is whatever it is, name equals John, for example. And that's the way you can set cookies as well through JavaScript. So you can set it with an equal sign, and then you can set document.cookie favorite food equals cookies, and then the path. So every time so this is, I want to make sure I emphasize that this is not like a regular object. So in a regular object in JavaScript, when you go document.cookie and then you put this name value thing, and then you do it again, what the regular behavior that you should expect, if you know JavaScript, is that it'll override whatever we wrote before. But because the way cookies are, because of the way that cookies are implemented in the browser spec, the fact that the fact that we're doing document.cookie and then creating a value, okay, or assigning a value to it, and then down here in the next line we're assigning another value to it, does not replace this value, because they're different cookies, right? So they have different names, and because they have different names, the browser will actually treat it as different. It would just get tagged on to this object instead of being reassigned, right? So this is not this is not value reassignment or assignment. This is like literally the way cookies are set up. We are actually it's more akin to concatenating a cookie. Like that's pretty much what's going on. So the next time you go document.cookie, if you were expecting favorite food equals cookies to be what you got back from that object, you'll be mistaken, because what you're gonna get back is both those values that we set, the name John and then the favorite cookies as your cookies that are set for that session. Okay, so just again remember that. So yeah. So document the cookie and then the name. So let's say we're got name with so again the key of the cookie that you want to delete. So like this is how we delete cookies. So you go document the cookies equals then the key of the cookie you want to delete, and then a date in the past. And then once you pass along, and then you call document.cookie again, at that point you would have deleted the document.cookie name John, and all you got back is just the favorite food cookies. So that's so yeah, if you were thinking that this is value reassignment, it's not. Okay, you actually have to go ahead and actually delete the cookie yourself this way in order for the cookie to clear itself. So yeah, now sending cookies over unencrypted HTTP is a very bad idea. Okay, and again, most websites nowadays, if you get a TLS certificate or something, then most of the communication is encrypted. But anybody, let's say that someone is performing a man-in-the-middle attack, which is something we cover in the DNS section of this course. If anyone sees that cookie and they're snooping, they can use it to hijack the user session. Okay, so if you're sending these cookies along kind of as raw text, as we saw in the request header without any encryption, then anybody can pretty much that's one way an attacker can assume identity over the victim and then perform any sort of attack at that point, right? So the attacker sends the victim's cookie as if it was their own, right? And that's how we were able to perform the bank attack, okay? And then at that point, the server will be fooled because the server doesn't actually see any difference from their point of view. The client made a request; it was a valid request. to a valid resource, and all the right cookies were sent, right? This is because the attacker got access to those cookies. Um, so yeah, the server at this point will get fooled, and that's one of the attacks that we're going to cover now. So let's just go over it in theory, and then we're gonna go see how this attacker is done. So let's see over here. So the attacker ingests a script. So the attacker somehow gets the user gets either the user to click on a link that they own, right? So to one of their websites. Then the victim authenticates the server, right? So they have some type of session live, right? So active. They have some type of session active to another website, right? So then the server returns the page code with the injected script, okay? And then at that point, the victim's browser executes the script and sends a session cookie to the attacker. And that's the attack that we're going to go over, the bank attack. I'm going to go over in detail how that happened. But again, you were able to see how, although we were logged in into a different website, the fact that we had logged in into that previously to the bank and our session was still active, then and then we went to a malicious attack, to a malicious site that had a script that was running. Then the server was able to perform that attack without necessarily the victim being aware of it, right? So let's before we get into that, let's go over some of the things that we can do to secure this, and then we're gonna go and actually implement the code. So session hijacking mitigation. Use secure cookie attribute. So there's this attribute in the cookie API that if you use it prevent cookie from being sent over unencrypted HTTP connections. Okay, so if someone tries to get a cookie through HTTP instead of HTTPS, then that way. So for example, at first, especially when submitting a form or something like that, if this is not set, then the cookie will be sent unencrypted, right? And then anyone pretty much can see the cookie, and then they can steal it at that point and then do whatever they want to do, right? So that's a no-no. Okay, another thing that you can do is session hijacking mitigation. It's use the HTTP only cookie attribute to prevent cookies from being read from JavaScript. So if the cookie HTTP only attribute is set, then all these things that the way we were accessing cookies from JavaScript, then at least that's it's you won't be able to do that. So that's another way to mitigate against this attack. And then at that point, then the server, at least the attacker can't, although it will be sending the request, and you will see it from the response and the request, it won't be accessible through JavaScript, okay? And then that's one way to mitigate that. Okay, so let's talk about how we can bypass the cookie path attribute that we talked about. So again, like I said, don't use this for security. It doesn't work, and we're going to cover we're going to cover an attack to show you how we can bypass it. But again, it should not be used for security. The path does not protect against unauthorized reading of the cookie from a different path on the same origin, and this is the main attack vector. So if someone's on the same origin as you, so if it's a subdomain or something like that, then someone can iframe it and essentially hijack the cookie as well. So again, it can be bypassed with an iframe. Then that iframe can be read with read.iframe.contentDocument.cookie. So iframe.contentDocument allows us to read the iframe's document as if it was our own document. We're going to cover that in just a few minutes. But yeah, so that's not if I think a lot of people used it in the past for and they have the misconception that this would allow for this to work as a security feature because it's set on a certain path. It's not. You can bypass it, and again, it should not be used for security reasons. So again, as long as it's the same origin policy, that's pretty much and an iframe can achieve this. So therefore, only use path as a performance optimization. Again, maybe you want to set the theme of a certain sub resource or like a certain URL to maybe a dark or light mode or whatever. Something very something that has to do nothing with security, and again as an optimization rather than as a security feature. So yeah, our cookie path secure? No, there is no solution against this attack. So if you're using this cookie path and you thought that this was secure, again, there is no solution. There is no way to make this secure, so it's always unsafe to use. Okay. So again, so now let's talk a little bit about what is the main problem, right? So we know that we have that we want a request to have this ambient authority, right? Because we want to keep some type of state across different requests. But the problem is that it's unclear. Once we have ambient authority, right, through cookies, then it becomes unclear for the server to know which site initiated a request, right? So consider this HTML embedded on attacker.com, for example, right? And then the browser hopefully includes bank.example.com cookies in all requests. And that's the attack I showed at the beginning, where a person had logged into their bank account, but then they, through either a link or somehow an attacker was able to get them to run a piece of JavaScript code on their behalf and submit a form. Then they were able to create a bank transfer in on behalf of that user, and we will cover that that attack in a second in detail. I'll show you the code for that. Also, yeah, so that was a cross-site request forgery, CSRF for short. So the attack which forces an end user to execute unwanted actions on a web app in which they're currently authenticated, right? So if you're authenticated on a different website, and then you navigate to a different website, but you're still authenticated on that website. If someone performs a post request, then those cookies will get sent, unless again you mitigate against that. I'm going to show you right now how to mitigate against that. So normal users, CSRF attacks can force the user to perform requests like transferring funds, changing an email address. So again, if you're logged into maybe Gmail or even WordPress, for example, then this can be this can be a lot worse, because once an attacker has access to your identity, if they log into, for example, as an admin credentials, and then they log into some WordPress website, then they can they can do SQL injections or attacks that have a different level of security access that are way more dangerous than a simple attack. For admin users, again, it can force admins to add new admin users on a database, for example, or in the worst case, to run commands directly on the server, right? So you can run like shell scripts even. And again, this if an attacker has this level of access at this point, you're pretty much hosed, yeah, you're kind of screwed. Okay, so like, don't let it get there. But it's this is with the CSRF method, it's possible to scale the access of an attack. So effective even when attackers can read the HTTP response, as we saw, because the way the browsers works and the way cookies work and the way requests work, they get sent the cookie anyways, as long as the user has been authenticated, right? So, and this is that concept of ambient authority, and these are some of the issues with it. So what are we left with, right? So what's the idea? Can we remove ambient authority when a request originates from a different website? So is that possible? Yes, it is. We're going to cover how to use that. And the way it's done is through another property that cookies have called same site cookies. So this came in the spec afterwards. So after a lot of these attacks were being out in the wild, and they were happening more and more often, and they we were able to see the escalation of attacks happening. Then the spec changed, and we created a new property on the cookies API spec that's called SameSite. So the SameSite cookie attribute is to prevent a cookie from being sent with the request initiated by other sites. So again, that attack that we showed of another user being authenticated, and then even though they're in a different domain, those same cookies by way that the request is that the user is still authenticated, the session is still active, then those requests would actually still go on, right? So, and then there's three levels, or three properties that three values that you can set on that property. The first one's none. So this is the default one actually, which essentially says SemSite equals none. This is the default behavior, and essentially what it says is always send the cookies, right? So this is what we saw. So unless you actively defend against it, there is no defense, right? So because the browsers by default have it set to none. Now that the next level is SemSite lax. I know it sounds like lax, like it's pretty relaxed. It's a lot better than none. What it does is, and this is probably a good default to have. Again, depends how you're looking at things and the filter you're looking at it through, the perspective. But I think none is fine. I think it should be on it should be on the developer the burden to like protect this type of stuff, because again, for tracking purposes and backwards compatibility, I do believe that same site none is the correct use, and only if you're a pen tester, or again, if you're a developer, then these things become relevant. But I do not think that users should have to worry about that. And again, because of, I think the more customizable the web becomes, I think we can create much better user experiences. And for that reason, but again, if it's an issue of CSRF, then maybe lax is the correct thing, because you would only want that experience to originate and then happen on the same domain or the same origin. But we can think of other experiences which are cross-domain, right? And if we're not just thinking of domains, but if we're thinking of the web as a full-fledged applications where different sites are pulling from different resources that can originate or they can be hosted on different origins, then I'm of the belief that with better tracking, and tracking maybe is a bad word, but the fact that we track user behavior across different websites, it simply means that we could create much better experiences that are customized to each individual user once the technology is there, right? So, but anyways, I think that's an opinion that we should all come to our own conclusions on that. But Lax kind of does that, right? So Lax withhold the cookies on the sub resources requests originating from other sites and allows them on top level requests. So if you're in the same origin domain, it allows it, and if you're in another domain, then it doesn't. And then there's this kind of same site equals strict, which is the most aggressive setting you can set, which only sends cookie if the request originates from the website that set the cookie, right? So that's like even subdomains on the same domain won't work on this, right? So same site strict is I think it's pretty aggressive, but again, it's there. And unless you're like a bank or you have some very sensitive information, maybe this is what you want to set. But other than that, there's probably not what you want to set, because if you do set it to strict, like let's say if you've seen any embedded maybe Facebook comments embedded on different sites, and then people can leave comments, but the comment box actually knows that you're still logged into Facebook, so it comes from you yourself, your account, right? That's a behavior that we kind of like on the web, right? And that's only possible because of the cookie session that you have from your Facebook account. But if it was set to strict, if that cookie was set to strict, then that wouldn't be possible, because that code that's embedded on a different website, which is again the behavior that use case expects, would not work for this, right? So again, very aggressive. I think Lax is probably the best security wise. That's probably the best for cookies that are sensitive. And again, the way you set it is on once you set the cookie, you put secure HTTP only. The path, always set it to home, because like we said, that should not be used as a security feature. And then you put as the last feature, same site equals Lax or none. Again, remember, none, you don't have to set it because that's the default. So that's kind of what it comes with when you don't set anything, or strict, right? So you can put none, Lax, or strict, and then that's kind of what you have. So yeah, so the way to mitigate cross-site request forgery, it's and we're gonna cover it in the code. So we're gonna run over the same attack, and then we're going to try to protect against it, defend against it, with what we've learned so far. Okay, so before we get into that, and I show you how to defend against the attack, some final thoughts on cookies. Cookies are used to implement sessions. Okay, remember HTTP is not a stateful protocol; it's a stateless protocol. So we use cookies to have this ambient authority and implement the concept or the idea of sessions across different requests. Remember, the server can never trust data from the client. It's not that the client is untrustworthy. It's more on the way that the web is created, which any request can come from any client, right? So it's a very flexible system, that the way the web is created, and because it's so flexible, it also makes it kind of in some ways also very vulnerable to attacks, because it has to it has to serve and accommodate all these different clients that might be requesting different resources, and it's not something that the server can necessarily control. So ambient authority is useful, but opens us up to additional risks. And if you remember one thing, say your cookie's like this, secure, HTTP only, the path, same site lax, and then expire maybe like 30 days, right, from when it's set. Again, you can always set the cookie again. So this is probably the best defense, especially when dealing with cookies. And now let's go over the same attack that we showed at the beginning, and let's see how we can defend against it.